front, so don't hesitate to come. You will have the best view from all attendees. Here, come here. There are still plenty places. Coverage of faces of some privacy extremists girls. Welcome. And I would like to continue with deeply privacy related talk. Arno Pfefferling came from far Germany to talk about HORIZEN and a platform that is recently being built on top of that privacy respecting, strongly respecting cryptocurrency. It's called zk-SNARK, and he's going to show that this platform has, according to Arno, quite interesting options and future use cases. And one of them is ZenChat. He's going to present for private messaging, but highly probably many others. So I would like to welcome Arno in Prague in our Congress, and I would like to pass over the word to you now. Thanks.
Yeah. 1, 2, 3. Do me a favor, show me 20 minutes. Is this possible?
Yes,
after 20 minutes? Okay. So also from my side, hello everyone. I want to add that this presentation, the next 40 minutes, are for educational purpose. And yes, I'm working in a privacy coin, but I will give you an overview. And first of all, I want to get back to the introduction and ask you guys, are you more interested in the decentralized application, or you're more interested in the privacy function zk-SNARKs? So please raise your hand if you're interested in the decentralized app. Okay. Now the question, zk-SNARKs, who is interested? Aha, okay, good. So you will see, this is the last part, but main part. And in the beginning, I just try to inspire you and to show you that we have a lot of opportunities generally in the blockchain space, and especially if we add up the privacy function. Then we have a short Q&A, of course, and in the zk-SNARK part, which is the protocol which we are using, I will just give some basics, and then we try to look in the advanced part. Okay, motivation. I think for me, I worked 7 years in the semiconductor industry. So what I right now see in the crypto space is that if I look in the use case of Bitcoin, then we might see the price doubles each 24 months. Or what we can see is that the user addresses increase, or the adoption is increasing. And in the semiconductor industry, where I worked for 7 years, we have the so-called Moore's law. And this is very interesting for you, because in an ecosystem, you can set your own rules and laws. And it's important because then you can put incentives, or you can inspire other people to follow this rule, to say so, which is bringing the whole ecosystem forward. And just a little bit of spoiler for you, you can scan these QR codes. These are like resources and links which I used to get more details, because this is a little bit short. So to make it more visible, I think this is for you the most interesting part, because the blue line, it's not readable, the blue line is tokens or decentralized applications over time. It's a logarithmic scale. This is important because in the Moore's law, we're also using a logarithmic scale, so that we have, for the increasing of the power of this integrated circuits which we're manufacturing, that's linear or almost linear. And if we now do this to the token amount, or add it to the decentralized apps, then we also see in the last 4 years linearization here. So this is like every 24 months the amount is doubling, which we also see in the Moore's law. And this is interesting because I know here the years are not shown. This is why when we compare it to the 90s, where we had this internet grow and we were able to put websites online, then we also saw this linear growth in a logarithmic scale. The interesting part right now, in this year, 2018, is that in the semiconductor industry, we are seeing now that the Moore's law actually is really hard to manufacture. That's why they say we have more than Moore's law, meaning they increase the complexity of the integrated circuits. And this, for the crypto space, now is like my own interpretation or interpretation for you, is that we have to increase the functionality of the tokens or the functionality of the decentralized applications which we're building. So I think if we look, for example, in all the other cryptocurrencies or ecosystem projects which we have, then it's clearly that Ethereum was like the king this year and last year with the ERC20 standard. But we also have, like it was mentioned in the presentation before, we have Hashgraph-like DHG blockchains, and of course we still have Bitcoin, which is a very well-functioning use case. We also have the treasury DAO functions, and of course this is the main part for me, is the privacy function. And all this I call like functionalities, or this is like complexity in our blockchain ecospace, and this is increasing and helping us to come through this boundary of adoption, or to come through the understanding how important our space is. Yeah, and then we have part 2. This is now getting in the zk-SNARK world. Here I have the chronicle or the history, to say so, for the zero knowledge and zk-SNARK protocol. In the 80s, there is Fiat Shamir for the guys who are more from the cryptography way or cryptology. They for sure know more about it. In the 90s, we got the SNOR protocols for zero knowledge proofs in the computation. And finally, in 2013, we had the Zero Coin, which was from an UK guy, Mr. Green, to say so, and some friends. Here's the logo. From there, we have up-to-date cryptocurrencies like Pivx, who are using the old Zero Coin protocol. And I think this is just a new logo for Zero Coin or Zcoin. And then, most important for the application which we built with zk-SNARKs, it's of course Zcash. Most of you know for sure the Professor Sasson from Israel. He published a paper in 2016. And from Zcash, we went to Zclassic. Then we have also Bitcoin Private. So the message here is our ecosystem is growing, and we are not like proving someone else wrong. So we are also trying to get the Bitcoin maximalists on the side of privacy, of course. And finally, we have HORIZEN here. I mentioned functionality and complexity are very important for me to come through the to break through the limitations. And this is actually what 2017 happened when the team of Buterin, you all know him from Ethereum, included state channels with a zk-SNARK option. Good. If Ethereum is implementing zk-SNARKs, what is actually a decentralized application? Because in a few slides I will show you the messenger which we built. We have 3 types. I think you're not so interested, that's why I asked. So the first is we are on blockchain. Bitcoin and Ethereum are fulfilling these. In type 2, this is where the messaging service sits. We are just consuming these tokens to make it work. To say so, what we are doing is we are making transactions, and this of course is consuming the coin itself. In type 3, I don't have examples here, but already type 3 applications, decentralized applications, are out. I think the definition, the majority of the audience was not interested. If you want to read more about it, please scan the QR codes. Okay, and this is actually now the type 2 DApp, which is using zk-SNARKs. And the special thing what we are just doing is we have in every shielded transaction in Zcash or in HORIZEN or whatever fork is coming from a Zcash-based coin, you have 512 bytes, which you now can fill, and this is encrypted through the zero-knowledge protocol, which I will show, don't worry. The special thing is that decentralized sounds good, but how much is it decentralized? Actually, right now, not much, because we are in the beta phase. So what we have a full node with the Sandemon running. We need to have the Swing wallet, and on top of the Swing wallet, we are doing RPC calls, like remote procedure calls, through Java to have a kind of mapping between the peer-to-peer partners. If you want to see more about the code, just try to scan the QR code, please. Okay, this sounds good because we have the privacy feature. We have the very good encryption from zk-SNARK, but actually the network itself is maybe also a big issue. That is why we, in HORIZEN, we added the node security. They are using an encrypted certificate. It's normally used for all the websites, SSL and TSL. We have this in C++. And from there, we can now do in this node network, we can directly do any RPC implementation. There are a lot of out there, so if you want to see some lists, these are also Bitcoin RPCs, you can just scan it again. Okay, so this was the boring part for the majority. Now we have the zk-SNARKs. I mentioned the 512 byte field. Now you're maybe questioning yourself, how is it encrypted? Because encryption sounds good, but why is it so special? It is special because in zero knowledge transactions or zero knowledge proofs, we have a very basic understanding of verifying something to someone else without showing the secret. And the easiest example to understand it is the so-called cave, or it's actually the picture from Wikipedia, so you also can find it there. It starts like this. On here, 4 on the side, there is Bob standing. He is the verifier, so he wants to know if Alice has a secret, and she needs the secret because this is a door where she needs to go through. This is the basic system and setup where we start. So Alice now Alice wants to prove that she has the secret to go through here, meaning Bob says, please, Alice, go to 1 or 2. Then Alice goes to 1 or 2. Then, when she is there, Bob was not seeing her going in this cave, so he doesn't know on which side he is. He just said, go on one side or another. Then, after a while, he goes here to 3 and is asking and calling now, Alice, please go on the other side. So, for example, if Bob stood here and said, Alice, please go to 1. Then he waits a while. Then he goes to 3 and says to Alice, please come out of the number 2 on the other side of the door. Meaning she needs to have the secret, but she's not revealing the secret to the verifier Bob. And this actually is done many times. And if you're from the math side, then you have this typical probability of success. Like if it's 100% right, for example, 1,000 tests is not infinite tests, but it's a limitation test. The probability is very high that she has the secret, because it's always can be that she's lying. So we have to work with probabilities here. A more technical one, and with more math, is if you want to Google it, homomorphic hiding. Is this basic situation for zero knowledge proofs clear to everyone? This would be the situation where you can ask questions, because from there we are building up more and more protocol level and other stuff. Clear? Good, great. Okay, now from here, if we now say we want to have a protocol which is doing this, what I described before, it can be done this way. It's just an example. Each coin which we have, or token we want to say, so we have a public key for this token, and we have a serial number for this token. Then every node in the network needs to have 2 lists. One list, this is this A list, with these coins in a hashed way. So we have a hash from every public key and serial number. The second list is a hash from the serial numbers which are spent. This is all the information which the nodes have, not more or less. Now if we want to verify that one coin or token Alice can spend, meaning she has the public key, she owns the key. We have a kind of a check routine, which is not shown here in detail, but we have to add the private key, of course, that Alice owns the serial number, the coin, and we, of course, have the hash. So, and only what she needs to show the network is the hash of the serial number, and then Bob and the other ones knows, okay, she can spend. The special thing is here that I think I jumped a little bit over it, that we have a succipient, non-interactive argument of knowledge, and this non-interactive is very important because Bob cannot like interact in between all this verification. So Bob has not the chance to say within these 5 steps, stop, Alice, I want to have some in-between check or proof routine. So this is all a flow and thing here. And okay, in point 3, we have this check. So we need the private key, pub key, serial number, hash. Only the hash identifies the coin which Alice wants to spend. And now we have to prove that she is able to spend it. And Bob, of course, will later receive it. And for this ownership proof, this is like where now the moon math or the math starts. This is actually just a G high R. So it's a modulus formula here. Then we have also this formula for C and for S. And this is like just a linear combination of this randomized R, which Alice chooses, and the formula from C, which is the hash of this one. Okay, so it's a little bit written sloppy, I know, sorry for that. So what we do is we have this T goes in a hash, then this C is just added with additional formula X to a random number which Alice chooses. This is the proof of the ownership for the coin 1. So now we have all these formulas, we have this X, we have this P. This is given by the protocol. And for example, in zk, how to set up the coin, this is called the common reference string. This is needed that we can build these formulas here. Without this like common reference string, it's not possible to make it work. And I told you R is random, and now what is only public is actually the hash of T. So this will be hashed and public, will be public in the network, C and S. And after this is done from Alice, now everyone can interact with this math. Now everyone in the node network can say, aha, Bob of course as well, and the network can prove with this formula if Alice was giving these 3 variables correctly, and if she can spend the coin and if she owns the coin. Okay, now I think if I repeat my question, everyone could follow this, then I hopefully get some hands. Or you're still with me? The G is a good question, yeah. I could say it's a typing error, but I think this would be easiest way out. Yeah. I think you're right. I think it's not a typing, but I missed it to put it here. So it would only make sense if G also is a parameter given by the system. Yeah. But thanks. Good catch.
Sorry, very How fast is this ownership compared to alternatives like confidential transactions?
Confidential transactions from what system or from what protocol, please?
From Windows, for example.
Yeah, of course it's slower. I will come to it. Where are the limits? This was the main message of my talk. Good question again. zk-SNARK is the most slowest, or it's a process which needs most computation. But we have solutions for that, so don't worry. I will get back to you. Okay, so this sounded easy. Now the most advanced part comes, because what I described was actually just some serial numbers and not like much randomized. If I now go to, okay, we want to do the moon math, which often Vitalik uses, we need to include polynomials. And polynomials, it's, I don't know if I speak it English properly, but it's this kind of functions. So you have a chain of x, or here x by x, for example. And with these chains, we say it's polynomials. And we need this to increase like the security and to increase the encryption of the system. You can shortly get through this through these words the whole process. Like you need arithmetic circuits. This is like rank 1 constraint systems. Then you need quadratic arithmetic processing, and then you end up in a zk-SNARK protocol. These are like the main steps. These 6 steps are actually describing this in a short way. So I'm trying to bring you these words in a like interpreted version from me. Okay, what we do is we set this equation, for example, which you also can find in the Medium post from Vitalik. It's the same equation. The thing is, Alice knows now the solution, and she wants to prove that she knows the solution and that she knows the equation without giving Bob this equation or without giving Bob the result of the equation, which is solving it. So what we have to do for the computation and to make it even possible, not even fast, to make it possible is we have to do code flattening, which is nothing less than, for example, here, this x by x by x. We split in x by x and then just add another step in computation with x. So what we are doing is we are putting this equation in a way how we can only use multiplication and adding functions in a computer language, to say so. And what we now then do after this code flattening, we have a lot of sub-steps. Like we have a subroutine, for example, for just the case of x by x, or we have a sub-case for just adding the 5, for example. And if you put it in math, you will see you have a matrix. So it's like a vectorial drawing of it. And if we say generally, we have this set of steps, or this matrix of sub-steps, aka subroutines or instructions, then we can build a transposed version of it. It's like just math. And this we can put in this written way. So we only need to have this vectorial Kreuzprodukt. So the, I don't know the English word actually for it. So we just need to multiply vectorial these two arrays, to say so. And this is now solving the equation in a splitted way that we can compute it very fast. The problem here is that this vectorial written way is not good for computation. It's now possible, this is great, but it's not in a way how the computer language or how the computer wants to compute it. That's why we do a so-called Lagrange interpolation. Worlds, they are also doing it to bring the coordinate system in another way. So I have like room coordinates, and the Lagrange interpolation is doing it now then in a graph-oriented math. Is this clear? Great, you're really good. And then we just have to do a dividing test of this S, like the subset transposed. We have to test if every polynomial, which is now coming out from the Lagrange interpolation, is able to be divided. And if this division is possible, 2 minutes? Ah, okay, thank you, great. Oh, thank you. So then, if the dividing is possible of this polynomials from the Lagrange interpolation, from this instruction set, then we say, aha, she's right. So the only thing which is now like seen by Bob mainly is the proof of this transposed substeps and the Lagrange interpolated polynomial vectors from here. Sounds very strange. The math is working because we have the protocol. To make it even more secure, of course, we have to add randomization to make an encryption out of it, meaning we have to do permutations. It's just like I put on, I don't know if it's here or it's there, I think it's here. We add up some like factors to make it different, but the result is the same. So I would not put too much in the last step here because it's more confusing you. Okay. So this is actually the hardest part to get. If you want to look in some details, it is described in several resources. I can recommend the professor from Israel. He's doing it very good. And finally, we have the honor to see the highest polynomials which they use, because in zk-SNARKs, the computation for elliptic curves, which is actually nothing else than this described polynomial. You have equation described by this way I showed before, and what they are doing is they are using some special cases. So here's, for example, a special case. It's they are numbered because they have like this thing here is actually just a graph tested several times. So what you will get is you have one equation or one special case. I know it's in German, sorry for this. It's in German because it's from Mittweida, so I want to say thank you to Professor Domen. Thanks for the slides. I'm using it. And what we have a field, and within this field, here this field size is 89 because we use this equation. We have this, to say so, test sum. So how is this kind of picture generated? Because it's a lot of 0 and 1s, a bitmuster. It's generated this way. You start at any point. You can start with any line in here. You will end up with the same picture. This is important to understand. So in elliptic curves, we start, draw one line, like one line here is shown. Then we have at least 2 situations where we cut, and then we mirror it. And this is the transposed version. Like here, it's also the same. We mirror here, and we have the mirrored image on this side. And this is done several times. So from here, I can do another linear, I can put another graph, and then I end up with 1, 2 more I think Schnittpunkte. Yeah, I end up with 2 more points where I cut this other elliptic curve. And this is done several times, and then I end up with such kind of image, which the SNARKs are using. And this actually now is the limitation, because it's a process which needs a lot of computation. Even so, if I do all these simplifications which I described, QAP or R1s, yes, even if I do this, it needs a lot of computation. What is the way out of this? The way out of this is that they already, like the Zcash Foundation with the mentioned Professor Sasson, started to do an improvement of the SNARK performance in the way that they use the elliptic curves, special cases, for example. They are really doing a lot of research. I think it took them more than 1 year to find elliptic curve functions which are still able to be randomized, but are the most efficient in computation. I think you can imagine it if you have a Grenzwertproblem. I don't know my English. Grenzwertproblem. So if you want to find some optimum in an equation, then you have to do some research. And if you find some of them, you can use them for your protocol, for example. The sapling, yes. And this is another problem. The trusted setup, so-called common reference string, which is needed there, is solved by the SNARK version of the Zero Knowledge Protocol from Zcash Foundation. And what they do is they make it from non-interactive to transparent. And in this case, they don't need it. Why they don't need it suddenly? It's because they are doing an FFT. So they are... I'm actually not 100% sure if they are still using elliptic curves, but what I know is that they are using the Fourier transformation to do the computation, and Fourier transformation can be done on specifically computer architecture very, very fast. And this is where they then can suddenly make it possible. Yeah, I think right now it's not possible on, for example, any computer. So I think this is the problem why it's not released yet, or why they might think we go for a different version. And
can you say in Node.js when you use the Fourier transform? What is it before the Fourier transform?
It's like if we go, I don't want to say something wrong, okay, because it's live, it's recorded. Professor Sasson is watching it, so I don't want to say something wrong. But I think what I described here, this Lagrange interpolation, this is replaced by the FFT. Or I don't have to do the Lagrange interpolation because these vectors, they for sure look different in Stark, and then I can do the FFT and don't need this one here. But I'm not a lecturer at the university, so this is just from someone who is in the Bitcoin space since December 2016, okay? Just as a disclaimer. Okay, and the other options, yeah?
I have a question. Have you heard of a zero-knowledge range proof? It's an open source improvement of zk-SNARK developed by ING Bank in the Netherlands.
To be honest, I have no way out, so I don't know. I did not hear.
Ah, okay.
I'm sorry, but you can
then I suggest you check it out and you share your opinion with me then.
Okay, but let me ask,
it's
still using elliptic curve, so.
Yeah, I mean, the difference is zero-knowledge range proof. I mean, the verifier is sure that the number, which is like the secret number, is from a certain range.
Ah, okay.
That's what it's all about, but it's 10 times less computational power.
Okay, then I would say it falls in the same category like this one, improving the SNARK performance.
Yeah, sure,
right?
Can be. But I think it has a major vulnerability, so therefore I wanted to hear your opinion.
area, or it's the array of the integer is limited somehow, then of course I always have to say, yeah, this sounds like it's not so highly secure. It's maybe enough for some transactions. So yeah, we can discuss offline. Yeah, happy to.
Use mic. Can you transfer over the mic?
I have to say, you waited for long for the hard questions, to be honest.
Yeah, but this all seems like an analogy of there was one type of congruence, and I can imagine that the mod p or modulo p means modulo sum prime, and bank systems and its securing are built on very heavy divisibility of by very high primes. If you know what I mean.
Yes, okay. So what he is, I think where your finger is pointing on is that the zero knowledge generally is in math using the highest prime numbers. This is a basic fundamental which I was not showing, but we need very high prime numbers to make it secure. And he's right, prime numbers we have infinite, but we have to find them. So there's a kind of competition to find the longest prime number. And this is a limitation which goes in the same direction. It limits the security of the whole system, yes. But I want to add up, because it's an interesting point to discuss, that these limitations, I mentioned the semiconductor industry and the integrated circuit manufacturing, because they always have to struggle with limitations, like physical limitations, like the nature is given, but they still are able to come through because they, of course, have a lot of money and the industry is behind them and stuff. But I mean, on our side, we have a different force. We have actually more power than the industry because we are open source, because everything is shared, everyone can put his knowledge in. So over time, I think with our ecosystem, we will overcome them anyway. So we will also solve this kind of issues. If it's Stark, maybe it's not Stark, maybe it's something else. There are other problems in the zero knowledge world, but I can tell you we will find a way through them and we will solve and we will improve generally. Yeah. Okay. Yeah, I think this is the Q&A already. So I want to say I'm happy to be here and it's a pleasure. It's the first time here.
So we continue questions directly.
Okay, could you tell me maybe something more about trusted setup in HORIZEN, because I had trouble finding some information about it.
It was in one of the podcasts from the CEO. We have the same CRS like Zcash has. So if the setup or this Genesis procedure from Zcash is somehow interfered or corrupt, then our coin is affected as well. By the way, it's for all. C-Classic the same, so everyone which is from Zcash, they are using the same common reference string.
Okay, thanks.
Yeah.
Other question, please?
Yes, hi. I have a general question about the maturity of these zero-knowledge proofs. Because normally in, let's say, legacy cryptography, right, you have an academic peer review of cryptographic algorithms which can last for, let's say, 5 years or so.
Yes.
If you look at the RIS challenge, for example, right? But also other cryptographic protocols and algorithms are peer reviewed over many years. Now, my impression of this blockchain and especially zero knowledge proof stuff is like it's the Formula E of cryptography, right? People are coming up, every technology really mature enough to put your money into it?
Oh, this is a really tough question to answer in an easy way, to be honest. But I want to focus maybe on the technical side. So what I know is that the Zcash Foundation and the professor from Israel, he is doing an academic job. So I would not say that they will hurry up because they see there's some more money. So if it comes to the quality of the work from the zk-SNARK, I would say it is okay. It's like fulfilling the requirements from other cryptology things. But I agree with you that this, of course, is abused in the way that we fork a lot of coins, or that we say, okay, we now have this and this way where it works better, and then no one is proving if it really works better. And in reality, it's kind of a hole in the system. I agree totally on that. But you know, this is like open source. If we saw a lot of errors and bugs in the ecosystem, this is part of it because we are open source and we are like kind of trying to avoid third-party checks. We want to check it ourselves. So I think this you have to have the awareness. Yeah, I don't put 1 million euro there because I know it's a system with a hole. And if you have this awareness, then the system is okay for you. So, but this discussion goes more in a general way, what is value in crypto and blah, blah, blah. So I don't want to go in this way so much. I just focus on the technical side of zk-SNARKs and the approaches which we see. There are academic papers out. They are good. They are still in discussion, of course. Research never ends. But they took like 4 years. 3 years. 2 or 3 years. And
thank you. We have another question here.
Yeah, sure.
Could you maybe please tell us a little bit about the enhanced Satoshi consensus that HORIZEN recently introduced, and it's part of the mandatory update?
Yes, I can. I think the Bitcoin users of you know that if we have proof of work and someone is privately mining and then is publishing his chain to the nodes, then it can override the other chain. This happened in our HORIZEN chain once. And what we did is we improved this mechanism a little bit. I'm not in this developer team who is doing it, but what I know is that if I'm doing private mining and then I'm publishing this mine chain to the nodes, then I get a penalty. So I still have to mine on this chain, and I need to, like, if I broadcasted it from the private side, I have to continue mining it, and this makes it harder to work on this fake chain. This is just a short answer. Is this okay, or?
Thank you very much.
I hope it was described well.
Is there a question before I pass the mic over to you? As you can see outside, evening is coming closer, and sometimes visitors and speakers and so on forget about very important part of Congress, which is not only lectures and workshops, but also parties in the evening. So please don't forget this very important part and come for the party. Will you come for the party before you ask?
Yes. Party with me. So blockchains, themselves tend to have network effects around users, security as well. You mentioned ZenCash or HORIZEN when it was called ZenCash. It had a 51% attack happen, which is I think a consequence of starting a new blockchain and basically having lower hash rate and stuff. Privacy coins in particular also have like another layer of network effect on top of that, which is the anonymity set of the users. Why would somebody choose to use a new privacy coin instead of using an existing privacy coin where the anonymity set, the security, the users, like the network effects across the board, but especially the privacy, anonymity set is already so much greater?
I would say because we have kind of still diversity in the privacy coins. So if I, for example, compare HORIZEN to Monero, they are different, definitely in a technical, very technical way. And if I look at HORIZEN and zcash, we are also different in funding models. So I would say there are differences, and one incentive to choose one over another could be the team, could be the approach where they go, could be maybe the DAO future or whatever future is like on their roadmap. So this could be one reason. Another reason, of course, is like economy. Like if I look at zcash, they are listed at more exchanges. So this could be a reason to go for zcash, and yeah, or HORIZEN is listed in an exchange where zcash is not listed, then I have to use HORIZEN if I want to do this or want to operate on the exchange. Yeah, and stuff like this. So I think there is not like hop or top argument. You just have to compare it for yourself and decide, yeah, I like the team, I met the guy, so yeah, why not using? It's this like the security, or you mentioned the network effect, it's almost the same. There are differences, of course, but technically, if I use Zcash or ZenCash, it's the same security, the same privacy. So,
isn't the hash rate a lot greater on Zcash versus
Zcash has the greater
Horizon?
hash rate, of course, because
So that would make the security greater, right?
If you compare to the 51% attacks, yes, of course, but for transaction security, like if my transaction is confirmed and true, then it's done. Okay, then I'm fine. Like my coins are safe. Yeah? No one can steal it anyway. So this is the same for all. So hash rate plays a role if I have a running system. For example, for the app, for the decentralized app, it's important because this was a question which we had, like, are we going on the public HORIZEN chain or are we going on the public Zcash chain, because we have both the zk-SNARK transactions, but we decided to go on the HORIZEN one because if a damage happens, then we have minor ecosystem damage in the whole network of privacy coins because we spammed, of course, the network in the beginning. So this could be some reasons.
Thanks. Yeah. Some other question, please raise your hand. We still have a couple of minutes.
Thanks for the talk. I perceive some discrepancy in how much your system relies on trust or tries not to rely on trust. So I'll try to explain on it. I would like to have your thoughts. On the one hand, you trust the Zcash trusted setup, which was made by 6 individuals, 5 of them from the Zcash company, plus Peter Todd. On the other hand, you go with the burden of using proof of work because you want to be decentralized and censorship resistant. So why not just go with, I mean, it's a bit provocative, but why not just go with having just 6 individuals validating the blocks and the transactions, since for other part of your system, that was your assumption?
It's a very hard question, but thank you. So first of all, why I'm trusting them is because I am not an investor there. Like, for me, is HORIZEN kind of a sandbox. So I want to show that we can do something with blockchain. I want to show that we can do something with zk-SNARK. That's why I take the circumstances of the creation of Zcash. If there would be an option to say I can avoid the trusted setup, then yes, I would take it. But on Monero, we don't have the option of 512 bytes in a transaction, a memo field where I can play around with any RPC calls. I don't have it, or I don't know of it. So this is why we choose the option to trust this and to start working there. So there is no right answer to your question. The circumstances are that we are there, they created it, so we have to use it. I would not recommend a financial institution to use any of these privacy coins, also because of the fact that in the network you actually don't know where are the funds located, like, or who owns it, like you have all the anonymity. So clearly the financial sector is not the sector or the industry for privacy coins. It will not be. Yeah, I don't know. Was this mainly the answer to your questions? It was so much, it was like 3 things. So, but I agree with you, this setup is not good, but right now we have no other options. There will be Stark, and if the Stark protocol is running, then we can say we remove this, and this is my generally thing. Over time, we will remove this centralized setup. We will go more decentralized and become decentralized. But somehow we have to make trade-offs in the beginning.
Last question. Is there some, please?
I guess you have also transparent transactions.
Yeah, of course.
Is there any limitation to use like private transactions by default or enforce it in HORIZEN or Zcash? Like only use private transactions, not transparent.
No, we have both. Like we have this this unshielded and shielded transaction.
Yeah, but I mean only using shielded ones.
For the app? Yes, we are actually yes, no. I have to be careful here because the fund mapping, like I have addresses and we map the funds that the user actually is not seeing how much crypto he uses. He's just seeing, okay, I sent 10 messages. This needs to be automatically balanced because in shielded transactions, what is more than the fee goes to some other addresses. So we have to do a automatically mapping of coins and addresses, but the decentralized app is only using shielded transaction because we do it on the memo field, and this memo field we only have in shielded transactions. Yeah. So
thank you very much for coming. I'm sure there would appear other questions, but Arno is here for other.
Yeah, I'm tomorrow here again.
And tomorrow again.
Panel, yeah.
So you can reach him personally. Thanks you for coming, and we continue. We continue here in Institute of Crypto Anarchy. We continued with lightning talks by Jim Warnock and Jakub Krčmář.